Underwater sea diving is a recreational or professional activity that involves swimming or moving underwater, typically using specialized equipment to explore, navigate, and enjoy the underwater environment. Diving can be done for various purposes, including recreation, scientific research, military operations, and commercial activities such as underwater construction. Underwater sea diving is a recreational or professional activity that involves swimming or moving underwater, typically using specialized equipment to explore, navigate, and enjoy the underwater environment. Diving can be done for various purposes, including recreation, scientific research, military operations, and commercial activities such as underwater construction. So now that we already have an idea of what underwater sea diving is, let us now dive into the body physiology of human sea divers.
What body preparation are done by sea divers before sea diving? Jacques-Yves Cousteau and Emily Gagnan created the demand valve system in 1942, which led to contemporary regulators and the introduction of scuba diving. The most common form of diving is recreational diving, which occurs in open water, uses compressed air as breathing gas, and does not require decompression techniques before surfacing. Technical diving is a name given to more extended and deeper dives that require specialized breathing gas mixtures, advanced equipment, and a pre-arranged decompression process. Apnea triggers the diving response, which causes decreased cardiac output, peripheral vasoconstriction, and vagally produced bradycardia. This response is linked to early hypertension and amplified by hypoxia and chilling of the face region. Increased peripheral resistance is a result of restricting oxygen consumption by non-essential muscle units and redistributing blood to vital organs. Bradycardia is induced to reduce the workload of the heart and restrict unnecessary oxygen use. The diving reflex is an innate motor system physiological response that protects oxygen storage while submerged in water. What body parts are greatly affected by sea diving? Sea diving impacts the respiratory, circulatory, and musculoskeletal system. Pressure changes can lead to lung injuries and decompression sickness. Blood flow is rerouted to essential organs during diving, which can strain the heart and lead to hyperthermia. Divers use several muscles and joints, and water resistant demands more effort to move. Equipment weight and buoyancy resistance can cause muscle and joint strain, and awkward posture and repetitive motion can lead to musculoskeletal problems, and proper training, equipment modification, and exercise can help reduce the risk associated with diving. What body part?
Breath hold diving involves various physiological responses, starting with subtle changes at the surface that trigger fluid shifts, alter blood flow distribution, and adjust cardiopulmonary functions and autonomic activity. Before diving, divers engage in lung packing to enhance lung volume. However, excessive packing increases the risk of lung barotrauma or pre-dive syncope. The mammalian dive response reduces oxygen consumption by initiating a vagally mediated decrease in heart rate and vasoconstriction of peripheral vascular beds. As the diver descends, peripheral vasoconstriction peaks, limiting blood distribution to non-essential organs. Breath hold diving involves various leads to reduced lung volume with increasing depth, but divers have achieved remarkable depths despite the risks of lung injury. Upon reaching maximum depth, nitrogen narcosis can cause transient amnesia, and during the ascent phase, lactate production may occur due to muscular contraction. Scuba diving uses a self-contained underwater breathing apparatus that provides breathable air directly to the diver's mouth. Engaging in diving activities introduces physical challenges to the body and can cause fatigue, skeletal muscle cramps, decompression sickness, and pressure differences in ears and sinuses. It is essential to use additional equipment such as a dive mask, wetsuit, and buoyancy control device and to dive with the body for assistance in case of muscle cramps. Upon entering the water, divers encounter distinctive physiological responses such as changes in breathing and the urge to urinate. The change in breathing is linked to the mammalian diving reflex or MDR triggered by the submerging in cool water. The MDR induces a significant slowing of the heart rate up to 50% and the peripheral vasoconstriction, redirecting blood flow to vital organs. The urge to urinate is attributed to immersion diuresis associated with vasoconstriction and caused by exposure to cold water. Alcohol and caffeine intake is cabaret research by acting as diuretics. Divers also experience heat loss and discomfort during diving. Upon entering the water, divers encounter distinctive physiological responses such as changes in breathing and the urge to urinate. The change in breathing is linked to the mammalian diving reflex or MDR triggered by the submerging in cool water. The MDR induces a significant slowing of the heart rate up to 50. Cold tolerance often determines bottom time limits, emphasizing the importance of maintaining the average core temperature of 98.6 degrees Fahrenheit or 37 degrees Celsius. Rewarming before repetitive dives is crucial, paralleling considerations for residual nitrogen levels and decompression procedures. The high thermal conductivity of water and cool underwater conditions pose challenges in maintaining proper temperature. Hypothermia becomes a concern with cold water entering the diver's suit, leading to increased respiratory rate, uncontrolled breathing, and impaired coordination. A water temperature of approximately 91 degrees Fahrenheit or 33 degrees Celsius is necessary to stabilize an unprotected person, and temperatures below 72 degrees Fahrenheit or 23 degrees Celsius results in rapid and severe heat loss. Additional physiological effects of cold water exposure include shivering, impaired work ability, dulled sense of touch, and decreased cognitive function. Appropriate dress is emphasized to mitigate heat loss and enable divers to work in very cold water for long durations.
What are the physiological effects of the water pressure to the human body? So, first up, let's talk about what happens to our hearts and lungs when we're. What are the physiological In terms of movement, your body feels lighter due to buoyancy, making it easier on your joints. But at the same time, moving in water requires more effort from your muscles. The pressure around you increases, making your heart work harder. This results in elevated blood pressure. So remember, your heart is your underwater hero, adapting to changing pressure beneath the surface. What diseases and illnesses are common among sea divers? Today, we're getting right into the heart of diving health. Let's uncover the most critical risks for divers and how to tackle them head on. First up, barotrauma. Ear and sinus pressure issue can spoil the dive. Remember, equalize pressure during the scene and ascent to pain and potential injury. What diseases and illnesses are common among sea divers? Today, we're getting right into the beans is no joke. Rapid ascent could lead to decompression sickness. Keep an eye on your ascent rate and follow dive table diligently to minimize the risk of the bubbles forming in your bloodstream. Dive control over oxygen level is crucial to steer clear of seizures underwater. Not a disease but a serious risk. Adhere to safety protocols to prevent drawing and ensure a safe ascent. Guard against hypothermia with proper exposure protection. Your body temperatures matters, so monitor it closely. And there you have it. The the essential insight to keep you healthy and safe underwater.
In conclusion, embarking on a journey into the underwater world can be a life changing experience and offers its own unique challenges, rewards, and opportunities for personal growth and exploration. The body physiology of human sea divers is a complex interplay of respiratory, circulatory, and musculoskeletal system, intricately influenced by the challenging underwater environment. Muscles and joints bear the load of water resistance, emphasizing the importance of fitness. As divers plunge into the depths, this physiological consideration underscore the need of comprehensive preparation from equipment familiarity to mental resilience, ultimately ensuring a safer and more fulfilling underwater experience.